Laplace transforms. Hey, this takes a little bit of time to develop, and as it gets developed, you might be wondering, why are we doing this? You just have to trust me, or you might even go and watch the last video and then back up to kind of see where it all comes from. So, Laplace transforms. Here's the goal. We have a function f of t. Just think about the traditional y is a function of t, y equals f of t situation. We're going to transform it from being a function of t to being a function of s. This is the symbolism that is used to demonstrate that transformation. L, obviously for Laplace, in script form is what's used. This Laplace transform is going to happen to produce a function of s. So we're transforming from a domain or an input variable of t to a domain or an input variable of s. I know, why? Well, just hang in there. I can't tell you everything right now. You have to kind of work your way through it. But that's what we're going to do. We're going to take a function of t, transform it by a Laplace transform into a function of s. Here's the Laplace transform. Again, you're like, well, where did that come from? Laplace. Laplace used his noodle, and he figured out that if we transform in this way, good things happen, you'll see. Integral from 0 to infinity. Yeah, an improper integral, 0 to infinity, of e to the negative st times that function that you're transforming. And I know you're like, whoa, what? To infinity and e to the minus? Yeah, it's all for the good, though, you'll see, to help us to do what we need to do. So we're going to transform y as a function of t to the f as a function of s, and actually we're going to solve that second order non-homogeneous differential equation in this domain, that s domain, and then we'll inverse back to the t domain. That's kind of the big picture. Transform f of t to be capital F of s, solve the differential equation in this domain. Now this is all in theory, you guys. And then back it up to get the solution in the domain that we want, which is the t domain. All right, so let's do some simple Laplace transforms. Let's suppose we want the Laplace transform of just a constant function. So we're going to create a function of s. Yikes. And we're going to create that function by integrating from 0 to infinity e to the minus st times the function that we're transforming, and I'm just transforming a constant function c. So let's work on that integral. I'll come over here and just focus on that integral. The integral from 0 to infinity of e to the minus st times a constant dt. Whatever happens with that is what we will call the Laplace transform of a constant. Now you all know that with integration, a constant can just be pulled out front, and all we have to integrate is e to the minus st dt. Now we're integrating with respect to t, so that s, that new domain, that new input variable domain, is a constant as we do this integration. So what is the integral of e to the negative st? Let's build it. The derivative of e to the negative st is e to the negative st. But we'd have to take the derivative of the stuff, the chain rule. The derivative of negative st would be a negative s. So we'll have to divide by negative s. And then we'll evaluate this from 0 to infinity. Now I'm going to kind of do this a little bit more sloppily, just because you'll see this gets a little tedious. We're just going to use our noodles and figure some things out. For example, if t goes off to infinity, what we're going to have is some constant stuff times e to the negative infinity. E to the negative infinity, 1 over e to the infinity. 1 over big is really small. So as t goes off to infinity, this goes off to 0. Minus, plug in a 0 for t. E to the 0 is 1, and so this is all just going to be c times 1 over negative s, or negative c over s. And so what we have here is a result of 0 minus plus c over s, or c times 1 over s. So what we would conclude is the Laplace transform of a constant function is that constant times 1 over s. Now, I'm going to stop here and we're just going to have several hopefully reasonably short videos where we're going to build a library of Laplace transforms. When we're all done, we'll have a Laplace transform of like a linear function like t. We'll have a Laplace transform of a quadratic or any power of t. We'll have a Laplace transform of an exponential. We'll have a Laplace transform of, we'll need some sines and some cosines. Now the idea is once we build this library of Laplace transforms, we won't have to do them again. We do them once and we make a library. And anytime we need to transform a function, we just look at our library and find it. Now, of course, with the internet, you could Google this right now and get the library. But what fun is that? You should build a library for yourself first, so that when you actually see the library or usually a table of Laplace transforms, you at least have some sense of where all this stuff is coming from. Now you'll have to watch all the videos and we'll have our conversations to get to the point of where all this is happening. So right now it might be a little fuzzy. Be patient. Keep going.